Hello everyone, and welcome to this weekly session that we conduct, Ask AuxEn Anything. And as you all know, that this is an online platform for civil structural engineers to interact with us and ask their queries related to any RCC steel design concept, construction site issues, or any project that they are doing. So this is the 45th such episode that we are conducting, and let us begin by taking the queries for this week. So I'll just open. We'll first take the queries from Google Form, and then we will take up the queries from the live comments. So let me just open this. Right. So first query is from. Let me see from whom the first query is. So first query is from engineer Manish Parmar. He is from Dehradun and he is a working professional. So he's asking, please explain. I'll just put it over here. Please explain clause 7.6.6.2 of IS 800 for lacing design. So that is his query. Please explain clause 7.6.6.2 for lacing design. So let me just open that IS 800 and try to bring the screenshot of it over here. 7.6.6.2. So this is related to lacings. Design of lacings. So in a built-up steel column, for example, if I were to draw over here, then this is my, let's say, steel column, and these are my lacings. Okay, and whatever I'm using, maybe flats or angles as my lacing elements, something like this. Now generally, for how much force do we design this lacing for? So if this column is subjected to axial load, then what is the force that we design the lacings for? So we take a notional load, assumed load of 2.5% of P. Okay. So this is not an actual load that is acting, because there was only axial load acting on the column. There was no lateral load in the column, but we take this notional load, and for notional loads we will design the lacing. That is the first part, what is given in 7.6.6.1. Now in 7.6.6.2, they are saying for members carrying calculated bending stress due to eccentricity of loading. So this means that, let's say, my axial load is at certain eccentricity. Basically what it means is that there is some movement in the frame now. So in the earlier clause it was only subjected to pure axial loads. Now it is subjected to some movements, or there is some actual lateral load, or uh, applied end movements. So there can be movements due to eccentricity of axial load, or there can be actual end movement. So in that case, then this 2.5% is not valid. Then you have to design for the actual shear due to bending. Okay. So this is what they are trying to tell you over here. But then the confusing statement is that in addition to that specified in 7.6.6.1, so maybe they are trying to say that this 2.5% of P plus the shear due to actual bending. in most of the practical engineers I have seen, they don't do this way. What they will do is, if there is some actual bending moment or some actual lateral force, then they will take that for the lacing. They don't then add up the 2.5% extra. But here, if you read the codal provision, it seems that they are saying to resist the actual shear in addition to that specified in this. So that means you will have to add up the shear due to bending moment or lateral force plus 2.5% of P. Okay. So actual shear due to bending or lateral, etc. So is this now clear? Is this provision now clear? Okay. So that is what it means. Then the next query is from uh, next query is from, okay, how to calculate if you have the bending moments given. If you have the bending moments, how to calculate shear? You can do M over L to get the shear force, and then L means the length between which the bending moment is getting applied, and accordingly you can calculate shear. Or you can create a small model, and let's say in your model you have the end moments. Maybe you are getting some actual shear also. Uh, let's say this was part of a portal, and this was the built-up column that we are talking about, and you had subjected this to some actual axial load moments, etc. So you will have the shear forces in this. So for those shear forces plus 2.5% of P, you design your lacings. Okay. So this was question from engineer Manish Parmar, and Mr. Manish is adding, then each lacing needs to be designed for full lateral load or some part. No, so if you have found out the, let's say you got the shear over here, okay. No, first let's take that there was some point load L. So this L you may divide it by 2 because there are lacings on two planes. I mean, the basic concept of lacing you have to keep in mind that if there are lacings on two planes, so lacing is over here and lacing is over here, and you have some lateral load L. So L by 2, L by 2, and then you have to design each lacing for L by 2 independently. And to that you add that 2.5% of P also. That is one. If you have some shear force, then the shear has to be, you need to sort of, if you have the shear force, you will have to sort of convert it into the load that gets transferred to this point by maybe some tributary width sort of calculation. So if you have the shear over this length, maybe you multiply that shear force, uh, or you will have to find out the equivalent point load that will be acting on this. Okay, so that you can calculate from the tributary distance between two lacings. Accordingly, then you design your lacing for that particular shear. So from the shear force diagram, you can sort of tentatively calculate the shear that will be transferred to lacings. So in that manner also you can calculate. Okay. Then next query is from, who is asking the next query? Okay, next query is from engineer Rohit Dogra. He is from Himachal Pradesh, and he is asking if there are two towers on single podium structure, if there are two towers with single podium structure, then we have to assign different diaphragms on podium T1, T2. So how can we assign wind forces, Fx, Fy forces, static, gust, or wind tunnel forces in user-defined option? Because three diaphragms are shown in the wind load user defined. No, so you can do it this way. I'll just show you an example of what I was trying to do. So just I have created from some old model that I had. I've just created this thing. If you can see on your screen, what I've done is there are two towers. Let's say don't look at the modeling right now. This was some other thing that was being done, and just for explanation purpose, I've just replicated it over here, trying to just show you. So here what we have done is that we have put diaphragms at these two levels. So maybe D1, D1, D2, D2. No, don't do it like this. Wait a minute. What I will do is just hold on. Just give me a minute. I'll just do a few things and then share my screen. Yeah, now let me bring that screenshot. Okay, so in left, so just for discussion purpose, I have brought this ETAB screenshot. So what we have done is on left side building tower, let's call it, we have assigned D1 modifier, and on the right side tower, we have assigned D2 modifier. Okay, now what you can do is you can just go to load patterns in ETABS, go for user loads, and once you go to user loads, then you will see that you will have those diaphragm options available with the nomenclature also. Let me just show you something like this. Do you see the screenshot? So now what you see on top of roof, for example, you see a diaphragm D1 and a diaphragm D2. I hope you are able to see. So this diaphragm D1 is what we have assigned over here in this tower, and this D2 is for the adjacent tower, diaphragm on the adjacent tower, and so on. So now you will see D1, D2, D1, D2, D1, D2 at every floor. So whatever wind forces, etc., you have calculated, then you can apply those wind forces or whatever you have calculated over here with each respective tower at each respective floor location. So this is what you can do. Is this clear? He has shared one screenshot also. Yeah, the same thing what you have done. Correct. Mr. Rohit has shared screenshot. Yeah, the same thing. So just a minute. So he had two towers. He has shared this image. Yeah, so he had two towers, D1, D2, and I think podium D3. No, D1, D2. Okay, I don't know where D3 is. Anyway, so on different floors, you have assigned these diaphragms. For one tower, let's say you have assigned D1s, and for the other tower, you have assigned D3s, D2s. So, in the same manner that I explained, you have also done. And then these wind forces, either you can calculate manually, wind or earthquake, whatever, or you can take these from some gust factor sheet, or let's say from internal testing, and then you can put it over here in this way. Is it clear? Yeah, so what you have done, I was also trying to explain you the same thing. So assign diaphragms, and no need to assign different diaphragm to different floors in one tower. So, for example, in this floor, all the floors, sorry, in this tower, all the floors you can just assign, let's say, D1 diaphragm. For all the floors in this tower, you can assign D2 diaphragm, and then go to load patterns, and let's say if you want to apply wind loads, go to wind loads, user loads, and then you will get this type of an option. Is it clear? Okay. Mr. Dhruv Panchal is providing or adding a related question over here. Is it necessary to analyze the entire structure together even after providing expansion joint on site? No, if you have provided expansion joint, then it will not be necessary to model this thing together in entirety, because you have already provided expansion joint. So they are detached. This question we are taking assuming that podium and towers are attached, and you want to take the complete, or you want to see the complete behavior of podium and towers together. So that is what we are explaining right now. If you have provided expansion joint, then they are detached. You need not take them together. Then Mr. Rohit Dogra has another query for which he has put this image. And what does he say? The If lift is coming on outer boundary line of building, then how can we design the lift foundation? Is this safe for overturning? So he has this lift coming on right on the boundary, and then these are the columns. So overturning, why do you think there will be overturning first of all? What overturning are you, which overturning are you considering? So in this case, let's say your general footings will be at this level. This is raft slab you have provided. What is this? That is not very clear to me whether this is a raft or raft. I'm not sure whether this is raft. Assuming this is raft, let's say. So for lift, what will happen? Let's try to draw a section over here. So what will happen over here, that for lift you will have to go 5 feet at least down, because assuming that, so situation will be something like this. Let's say this was the column and this was the column on the edge. So situation will be like this, because this is the raft and you will have to have the lift pit. This is, of course, we are assuming that this is being used as a basement. So this becomes your situation, and therefore you will have to provide, let's say, beams, deep beams like this, all across, all around the periphery of lift pit. And over here, maybe you can also have a wall in this portion. You can add a wall, and these are your walls, because this was 1500 mm below the main basement draft level. So overturning, I'm not sure why are you worried about overturning. Which type of overturning are you worried about? I'm not very sure from this question. But this type of an arrangement can be provided. If let's say there were heavy lateral loads, and on this column there was large movements for which you are worried, then if your soil allows, maybe you can think of providing piles over here to take that additional uplift or tension force that might get generated. And because you are not able to extend the footing beyond this face, so in that case, Assuming that there were very heavy, very high lateral loads, I am answering this. So one of the options, if your soil strata is weak and clay is sandy type of a strata, then you can have piles provided like this just below. Or if you have a harder strata, then you can think of providing some anchorage through reinforcement bars drilled inside the hard strata. So these can be few options in case you are in case this region of your building is subjected to very high moments, because of which you are unable to manage the bearing pressure. So that can be one of the ways. Otherwise, around lift generally you will not see a lot of issues. And the other way, of course, can be to thicken the raft for better load distribution. So generally around lift, because it's not loaded very heavily, uh, yeah, these columns might be, but otherwise it's not very heavily loaded. So it won't be much of an issue. If it is, then you can come up with these solutions. Okay. Next query is from, let me see who is asking the next query. Next query is from engineer Harshad Nayak. He is from Navi Mumbai and he is a postgraduate student. So he is asking how to model and design steel plate shear wall steel building in SAP 2000. Also, can you suggest some reference? Reference, I think you can refer to AISC 341, which is seismic provisions for steel buildings, that has a chapter on steel plate shear walls and modeling aspect. You can do it as per the plate elements, plate use the plate modeling, or what you call as the shell modeling. So using the shell modeling, you do the model just like you do, let's say, RCC shear walls or RCC structural walls in ETABS or STAT. Similarly, you can do the same thing using the shell model to model these steel plate shear wall in SAP 2000, and then you can assign the thickness requirement accordingly. Design part, you need to refer to these codes. You can refer to AIC 341. Also, there is one NEHRB document that I'm just trying to locate over here. If I get it, special structural shear wall. Is this steel or concrete? No, this is not that. Just a minute, I'm just looking for. For steel shear walls, there is one document, I guess. Uh, I'm not getting it. Steel shear wall. Okay, so there is an AIC design guide number 20 for steel plate shear walls. So you can refer to that also. Okay. So there is this AIC design guide number 20. You can refer to this also for steel plate shear walls, or you can refer to AIC 341 for that. Uh, okay, wait. Let me just answer this. Okay, so these two documents I can think of, and you will get, I think, sufficient information from there. Okay, so this was engineer Harshad Nayak with his query. Now, so these were all the queries that were put on in the Google form. So now let us take up the queries from the live comments. So live comments, Mr. Mayur Prajapat, engineer Mayur Prajapat is asking, Can you explain which formula we need to use to calculate time period for dual systems 0.09 h over root d, or structural wall time period formula, or maximum of both? Now the code is very clear in what needs to be done. So if you read the provision, code is quite clear. I'll just open and see if we can discuss that. Let me just open. And I think there is some amendment to that formula also. That 0.09h formula, I think it has been amended. I don't remember, but I think it was amended. Okay, assuming it has not been amended, I'll just open the provision first and let's figure out if we can make some sense of it. Yeah, I guess this is the time period formula. So buildings in RC structural walls has to be done like this. They have given you the formula. All other buildings, they have given you the formula. And this AW calculation also they have given. Now for dual systems, which time period to consider? So you should buildings with RC structural walls. You calculate according to this and follow this guideline. Calculate the 0.075 h to the power 0.75 divided by under root AW. This time period has to be greater than or equal to 0.09 h over root D. So accordingly, you calculate both these values and then take the appropriate time period. Because a dual system has RC structural walls, so we will go with this provision B, and accordingly you can do the time period calculation. Okay. Yes. Then Mr. Mayur Prajapati is asking, sorry, one more question. If our structure has podium plus basement, then where do we need to match the base shear, at base or at ground or at start of tower? See, base shear always, please understand, base shear is the summation of all shear forces. Okay, base shear is summation of all shear forces. Yeah, now this is not very clearly given that if you have a podium and if there is a case of shear reversal happening, then what you should do. So that thing is not very clearly given anywhere. But let's say if you had this podium level and there was a shear reversal happening, that means uh, my shear forces were adding up like this, and suddenly the shear force changed its sign due to large reaction from podium. Then I think you should do the base shear scaling at this level, assuming this is the final level, and above this you calculate the summation of all shears, and you calculate the summation of all shears for dynamic, and then do the base shear scaling. So if a shear reversal is happening, then you do it like this. Otherwise I think you should do the base shear scaling at base if uh, shear reversal is not happening. These are my views. This is not given anywhere in codes, but this is what I think of. Okay, this is what I can think of. All right. Hi, 12373 saying hi. Okay, hi. Then Mr. Arbaz is asking, in RCC structure we have to design only gravity members for R times displacement or else provide ductility. Both. No, so okay, sorry. Gravity member, R times displacement, and then you provide. So this r times displacement, why are we considering these additional moments? Because the compatibility of deformations have to be maintained, and therefore you design the gravity columns for r times the moments. No need to provide ductility. That's the reason why we are calling them as gravity columns. Then Mr. Arbaz is asking, do we have such concept in steel structures? Yes, we have. So if your system is not part of moment resisting frame, let's say, then those columns or those members, you have to design them as per the principles of gravity columns only. Yes. So this concept is there for steel structures also. Okay. Then what else? In depth 5677 is asking, if there is raft up to 3 meter depth and shear wall is resting on the raft, then is are the vertical bars needed to be taken up to LD distance, or do we need to go up to bottom mesh of the raft? See, from practical viewpoint, it will be better if you can take up to the bottom. Technically speaking, what his question is that I'm showing you a cross section. There is this raft, 3 meters, very thick raft. I'm showing you the sectional view, and then there is a wall starting or column starting from this. Now, because this was and this has, let's say, 25 dia bar. So his question is, can I just terminate my bars like this? Because already I have got LD distance, the curved length plus hook length, etc. add up to LD. And let's say I have also the straight portion is equal to LDC. So that is coming to be around 400, 500 mm. So do I need to take my bars right till the bottom? Because that means I'll have to have a 3 meter additional bar length, which will add up to my cost. Or can I just terminate it over here? So technically you can terminate it over here. Technically you can just terminate it over here after providing the necessary LDT and LDC values. But from the practical point of view, so what will happen is that supporting this reinforcement cage before concreting is done will be difficult, isn't it? Because it is hanging or suspended in air right now. So maybe then you will have to provide some chairs to rest this. So that might be done. So technically, if you ask, yes, you can terminate the bars after LDT and LDC, and then because your reinforcements are hanging suspended in the air, you can provide some chair below it. But practically, if you see on site, people like to take your reinforcement right till the raft bottom. All right. Yeah. Yes, you are right. If we go till bottom of mesh, then a lot of steel extra we have to provide, because 3 meter depth we have to add up to each bar. So yes, technically not required, but practically it is done on sites. Is it practical to make connections as semi-rigid, because usually we prepare spring model having spring supports in E-tabs? You may do, actually what happens is that this footing to column junction you are asking about, whether to design it as a fixed support or a pin support, is this what you're asking? I think this is what he's asking. Yes. Yes. So that is a mixed opinion. Some people say that because this is uh, uh, a cast in situ monolithic joint that we are preparing, because you have developed your reinforcement to LDT and LDC, and because the support provided by soil mass is such that in normal conditions there is no rotation as such possible. So therefore many engineers and many books that you can see, they allow you to have a fixed like support. Now there is other viewpoint also that let's say under the effect of wind loads or lateral loads, momentarily let's say there is a rotation that you have allowed. Why rotation? Because you are allowing, let's say, uplift in some portions of your footing under wind loads or lateral earthquake loads, and under some portion of the footing there is a downward bearing pressure. In some portion of the footing you have allowed uplift. So at that point, what is happening? That this system undergoes a rotation, let's say. So if it undergoes rotation, then engineers or book writers think that it can be idealized as a pinned condition. In general situations, it is more like a fixed condition. In this kind of a situation, it is more like a pinned condition. So then, most of the engineers, what they tell is that you may design your columns for both fix and pin, and then provide whatever is the worst case. So this is also a practice that many people adopt, that they will design their columns, analyze and design their columns, beams, etc. once assuming a fixed condition, once assuming a pin condition, and then providing whatever is the worst. In case of raft also, somewhat similar principles may be adopted. Although this discussion is more valid for pinned, because in pinned footing, this discussion is valid more for isolated footings, because in isolated footings there is a chance of rotation possible under effects of lateral wind, which might not be there in case of raft. So yeah, I think in raft you can just go ahead with fixed conditions. In isolated footings, you can try it out for both pinned as well as fixed conditions. Okay. Mr. Mayur Prajapati is continuing with his earlier question about time period. What he is saying, in case of structure having podium, we consider L and B of podium or tower for calculating time period. So again, not much clarity is given. If your structure, see, the idea should be to calculate the lowest possible time period if you are using these time period formula, because lowest possible time period would mean highest possible earthquake shear. So whenever you are calculating time period, just try to take the lowest possible time period. So that means, suppose this is my section, this is my podium, and this is my tower, and this has certain width b1, and this has certain width b2, and I have this type of formula, let's say, and where earthquake force is in this direction. So this becomes my D. So now will I take B1 or B2 in the D calculation to get the highest time period? What do you think? So if I want to get the if I want to get the lowest time period, whether I will take B1, whether I will take this dimension as B1 or B2. Remember, I want the lowest time period possible. So then I might go for the higher dimension B2 in that case, so that I get the lower time period. So these things are not quite clearly given. Uh, there are now new diagrams given in IS 16700 for the width, for the height to consider in podiums. So you can refer to that picture, IS 16700 2023. There's a picture given, there's a figure given about the appropriate height of the building that you should consider, but I think it does not say much about the width. Let me see. So basic concept, just try to remember that you would want the lower time period. Accordingly, you choose the width and depth, or B and D of your structure. Okay. All right. Now there is no figure given in 16700. Yeah. 1893 page 22 has given for heights. Correct. Not only irregularities, that is general figures given for height. Mr. Magaj is asking where can I get the load intensity of 10 tires vehicle? Maybe you refer to IRC 6. They have different loadings given, different wheel loadings for different load class. So I think IRC 6 will help you. All right. So these were the questions asked on the live comments. So we have taken up the queries from live comments also. We have taken the queries from Google form. Now, if there is anything else, we'll take it up, or otherwise we will close today's session. So is there any other query or point? Okay, so I think there's no more queries. So that's it then for this episode. Oh, he asked another question. Where is your other question? This? Those springs provided is for providing only till LD. Is it considered as semi-rigid and going till bottom mesh considered as rigid? What does this question mean? So, no. So even if you're not taking it to LD, you're in case of raft, you will be providing supports over here because of the soil. So you're not going to provide support over here. Your soil supports have to be provided at the bottom. Yeah. No, I don't agree with this statement that is it considered as semi-rigid when we are taking the reinforcement till LD and taken as rigid when no, that is not happening. You if you have see if you have taken it, development length has been provided, the joint is being cast monolithically, you consider it as rigid. Now if you have decided to take the bar extra from practical viewpoint, still it does not change the uh, joining conditions as such. At column ends, yeah, in case of raft, your support is provided by the soil, right? So I'm saying you provide soil springs. Here you assume it is just rigidly connected because you have provided LD development length, and because you are going to cast it monolithically, the joint between column and raft you consider it as a rigid joint. Okay, all right. So yes, thank you, Mr. Mayur. So that is it for this session then, and we will see you again in the next session. You know where to put your queries. So the link for Google Form remains the same throughout the week. You can put your queries over here. Once every week when we meet during this live session, we will take up your questions. Mr. Mahel Prajapati is asking, can you share the amendment of the code? You will get easily. You will get it online. Just type in IS1893 amendment, or you just send me a WhatsApp message. I'll send you the amendment that I have. Yeah, so this form remains the same for putting your queries. And if you want to connect with us through message on WhatsApp, this is our this is the link to reach us on WhatsApp. So I'm just putting that link over here. Where is it? Yeah, so this is the link if you want to connect with us on WhatsApp. Right. So then that's it for this session. Thank you. And now we will see you next weekend with another episode of Ask Ox and Anything. Till then, have a good time. Bye bye.